Welcome to the MS Dev Show, episode number 199. This week we talk with Chipalo Street about the IoT Edge, how to convert your Surface Pro into a Surface Studio, and why your next processor may contain tiny roller coasters.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Chipalo Street, Principal Program Manager working on IoT Edge. How's it going, Chipalo?
Pretty good. How are you guys?
Doing well. So, Carl, I just finished my RV trip. I'm in my house. As you can see, I'm in my bedroom. My office does not have any doors yet. I have to get those put on so that I can take calls in there. But at least I have a nice quiet room here. And, I think we talked about this before, but I have my AT&T gigabit fiber all set up and I'm all hardwired in. So we can put some of my speed tests in the show notes.
Yeah.
Carl's super.
Those should be automated at this point.
Yeah. You can automate them through Ubiquity, by the way. So we've been talking about having like a ultimate networking setup or something, because I've been building out a pretty cool network here at the house. But the RV trip is over. And then I did get some questions on our Slack channel about the trip. So, it was a little over 2,000 miles. I'll see if I can grab some stats that we can put in the show notes. But I did get questions about how I was working during that with the drive. So, I'll kind of make a long story short here. There were only 5 weekdays that I had to drive during the week. So I took vacation on those days. The other drive days were on the weekends. And, since we had almost a month, the vast majority of the days were actually in one spot. So for example, we were near Denver for 9 days. So we, obviously there was no driving for a long period of time there. So that's how I pulled that off. And then I have the unlimited AT&T hotspot. And unfortunately, the biggest challenge was some not so reliable internet in some places. I have a giant booster, but anyway, if you want to hear more about that, I'll run an open space at that conference in Wisconsin Dells. What is it? When is that, Carl? Is that next week?
That's next week already.
Yeah.
A week from today, we'll be there.
So you might be listening to it after that conference, and you may have already heard all the details from me, but I'm going to have to prepare for that. And I'll bring all the details so that you can learn about how to do extreme remote work and be able to see the world while you're working. So anyway, let's jump into the comment of the week, Carl.
Yeah, and it was RV themed as well. So Dan Vanderboom reached out to us on Twitter. Mm-hmm. It says, it was interesting to hear you talk about RV life for tech folks or other people. Have you heard of the autonomous RV concepts? This sells it for me. Positioned as a service, but can imagine owning one to live in full time. Without ever having to drive a beast of a vehicle. And he sent us a link to a YouTube video for something called TerraVenture, which is an autonomous RV. And I think some of the tech is a little ways out yet. And I think you agreed with me on that one, Jason.
That's putting it very politely.
Is this like self-driving cars on crack, but for RVs?
Well, it's a self-driving electric RV, and they want to sell it as a service.
And in addition, like when you are camping somewhere, they even have like drone delivery stuff of like when you need.
I know. If you watch the video, like I understand that the whole thing is sort of aspirational, but like I was thinking that it was like a concept video, which it really is. But then you realize they're like, we formed this company. It's like, okay, so what does your company actually do today? Because everything you say you do actually doesn't exist yet.
They just sell RVs. They have like a RV lot somewhere.
Yeah, we just sell cheap RVs. But basically, I think the idea though is that you actually pick like a vacation package. You say like, I want the Mount Rushmore package or South Dakota. All right. You click a button and then 2 weeks from now when you schedule it, like this RV pulls up, you load all your stuff into it. And then it drives you there. And then it just it just stops and is like, get out and go look at Mount Rushmore for
well, they also had
hours.
part of that where like you could stand in there and then they would have like a self-guided tour. So they would be like pointing out like, like here's the history of this president. And
yeah. Here's a self-driving Segway.
Right, so the parents can be happy and the kids can be super annoyed. You can annoy your kids at the same time.
Yeah. So I don't know. I thought it was super aspirational. Like people have to sort of think of what the future holds so that you can kind of, figure out how do we actually get there. But I just thought I really wish they had like painted their vision of, well, that's where we want to get to. And here's what we can do today. Because there was no indication of what they can actually do today. Like you said, it's just, here's an RV. You have to drive it yourself. You have to fill it with diesel fuel. You have to plan your route. Everything is on you for the time being until we automate it all away.
It's fine. They're on the Elon Musk plan.
Yeah.
Hyperloop, inspirational.
Yeah, exactly.
All right, so if you want to get mentioned on the show like Dan, send us an email to feedback@msdevshow.com. Comment on Facebook, YouTube, or Stitcher. We also really love those 5-star iTunes reviews.
Absolutely. So let's jump into the news. We have a couple of quick stories. So the first one here, Kensington Dock turns the Surface Pro into a mini Surface Studio. What?
Yeah, I mean, you watch the video for this in the show notes, and this is pretty cool. So you take your Surface Pro, you put it in this dock, and it kind of lets it go flat and elevate up, just like a Surface Studio does, and it looks really cool. Plus, you get the benefits of it being a dock, so you can get external monitors, other accessories, and like your keyboard, mouse, and all that just plug in and work. And it looks just really beautiful. And I forgot the price. It's like $300 or $400, but it looks.
I was going to ask you, yeah.
It looks like if it does what it says for the right
$300. That's not terrible. Because I was looking at this. I mean, it's just
what's a Surface stock, like $200?
Yeah, I think it's
probably more reliable
price
than that.
Yeah, this is pretty cool. I mean, it's just a good stand. I mean, if you look at it that way, but it's a stand plus dock. So yeah, I mean, extra $100. Let's see what ports it's got here. So it's got USB-C. It's got 4 USB-C ports. It's got Ethernet. I'm like looking at the video. DisplayPort, USB-A, and then power. So I mean, so it's like a dock plus stand. So I would consider buying this over the dock.
Yeah, it looks really nice. I'm all for it.
Yeah. So go ahead and order me one. Okay, next story. Someone built a calculator out of roller coasters.
And to be clear, it's not just roller coasters. It's Roller Coaster Tycoon, I believe, is the name of the game. And this was actually, I watched this whole video like beginning to end. And there's an imager that we'll have in the show notes that kind of like break it into still images and descriptions. But this guy built this massive custom roller coaster that you kind of plug in some single digit numbers, 2 of them, and it'll add or multiply them. But when you watch the roller coasters, they're like doing jumps, and there's these things that it does to like speed up and slow down them to kind of like make the calculations work. This guy definitely has a knack for what the game can do, and very creative usage of it.
Yeah, most people don't realize that in your processor in your computer, there's actually little roller coasters in there.
Just crashing roller coasters left and right.
No, this is really, I always love seeing this whenever, I think this would be an interesting way of teaching students how computers work at a fundamental level. I know that when I was in college, we had to build, we had to design essentially processors out of like NAND gates. But I think this is really cool because it shows you logic at that fundamental level. And I think this is kind of a neat way of teaching it for sure. I don't think that was the intention, but I think it's a really neat demonstration. Okay, so the last story here, the Rockstar programming language definition.
So first of all, this is a proposal for a new programming language called Rockstar, and it's kind of set up so all of your code, if you do it kind of in the theme of what's intended, it sounds like an 80s Rockstar ballad. Like for like a one-line example, it's they have Tommy was a lean, mean wrecking machine, and that definitely sounds like it's something out of an '80s rock ballad. But ultimately, at the end of the day, what he's hoping is this becomes actual enough where you could say, put on your resume, "I'm a Rockstar programmer." And he hopes that this is a terrible enough language that it actually becomes demeaning so people can stop saying that companies can stop asking for Rockstar programmers.
Right. Because as we know, that's like it ends up being a very sexist term. Not necessarily intentionally, but as a side product, it ends up getting interpreted different by men and women, and you end up limiting your the diversity of the candidates that you have applying. So that's pretty cool. This is an interesting way of trying to get rid of that.
Yeah, but there's some really cool examples that shows FizzBuzz in there, just kind of like how you would probably do it if you kind of like took your existing skills over, and then a way to do it like if you really were embracing the language. And it actually is pretty hilarious, the ideas.
Yeah. Oh yeah, so FizzBuzz.
Yeah. So if you look at the top one, it's like very obvious that it's FizzBuzz, but if you look at the bottom one, it just sounds like a song.
Yeah.
So we don't want to say those out here because it's going to.
We should have Brandon Martinez on to come on and write and actually play it out.
Maybe we can do that post show.
Yeah. Hey Chipalo, how's your singing voice?
Oh my God. It'll save everyone. I'm in an office, not in a shower. In the shower, it sounds great.
Yeah. Very cool. Okay, well let's talk about the IoT Edge, because I think this is a really cool thing, and it's actually something I know that Carl's done a lot of work around this, and I've done a fair amount of work with some partners on it, and like Edge is the big Microsoft buzzword right now, and this fits into that whole strategy. So I think what we should do first is sort of take a step back and just define what edge means. So not the IoT edge, but we hear like Satya Nadella talk about this all the time. He talks about intelligent cloud, intelligent edge. So what is the edge?
Sure. So I think edge means something else to every different person, depending on where you are in the tech industry, right? Like It's almost like the term gateway. Gateway is a super nebulous term that everyone has and everyone's interested in. And so for us at Microsoft, the edge is devices that are running locally on premise. That's not in the cloud, so not in a large corporate data center, but probably controlled by the end customer and locally on premise. Now, if you go talk to a telco, we share the same view of edge not being in a corporate cloud, but they may think that the edge is closer to, say, their cell phone tower or something like that, as opposed to on the end user computing hardware. And they're both equally valid ways to look at it, depending on what scenarios you're trying to tackle.
Mm-hmm. Yeah, I always thought of edge as like, you could think of it as on-prem, but there's also, with all the on-prem stuff, there's like stuff in the middle, which is things that don't, aren't like close to the internet. But I always think of them as that thing that is sort of like the thing that's close to the internet. If we drew a diagram with like the cloud on the right, and then on the left we had like stuff that was buried deep behind the firewall, the edge would be the thing on the edge right before you get into the cloud. I mean, is that accurate? I mean, is that how it's used as well?
Well, I mean, that question always becomes is the edge of what, right? And so that's why it really changes based on what perspective you have.
Yeah.
If you're the end customer, it's the edge of my network, which could be the thing that touches, and even if you're a customer, it's like the edge of which network? Is it the edge of your OT network on your factory floor that touches the edge of your IT network that touches the internet, or is it the edge of your IT network, or is it both? If you're a telco, is it the cell phone tower? Is it where it backhauls to the internet before it goes to the like corporate cloud or something like that? So it really depends on the viewpoint from where you're coming.
Yeah, that's a good point.
So then looking at it from the Microsoft perspective, what is IoT Edge and what have you and your team been working on?
Gotcha. So we provide an extensible product that can be run on whatever hardware you have for whoever you are. So if you're an end customer, you can deploy it in your OT network. You could deploy it in your IT network. If you're a telco, you could deploy it under your cell phone tower. But the real technology there is about offloading cloud services from the corporate cloud like Microsoft Azure and running them on the local hardware that you have so that you don't have to send all your data to the cloud, so that your solution operates when you don't have internet and that you can get more real-time responses. Like a lot of people's internet infrastructure is good enough to get near real-time by going to the cloud and back. However, sometimes there's a need to have sub-millisecond response times, and running it locally can get you that.
Yeah, exactly. So how hard is it for me to then port my existing code to IoT Edge if I want to run, if I have just some existing code that I'm already trying to get those sub-millisecond times out of, how do I get that in there?
I mean, what's super cool is that we're using containers as the deployment mechanism for code, and containers are just any type of code that you want to run. So it's really easy to get your code up and running in a container.
Okay. So honestly, like I saw a tweet and I should have grabbed a link to it, but they were saying, what was the tweet? I mean, they were talking about how like really everything should be running in a container these days.
Yeah.
And I think that's the general philosophy that people have. So, if you're following that mantra, then it sounds like it'd be pretty darn easy to bring your stuff into here.
I mean, if you think about it, containers are kind of like processes running in isolated namespaces, right? Like all of your code runs in a process anyway. It's just whether it has access to the resources of other processes if for some reason your code breaks out of your process. And so containers do a good job of isolating those things. But it's a really lightweight concept. People hear containers as like, oh my God, like I'm running in a container, therefore I've added all this overhead to my code and it's so much slower. But like it's something that's built into the operating system, and it's simply about separating processes and making sure that they stay in their own swim lane.
Yeah, it's almost, not to turn it into a container episode, but I mean, it's almost like zipping up your code and just using that as like a distribution mechanism. There's obviously way more to it. But if people are afraid of like putting their stuff into a container, would you be afraid to zip it and like deploy it somewhere? Of course not.
Yeah. I mean, I think one of the hesitations that people come up with is like they equate it to like a JVM or something like that.
Mm-hmm.
But the problem there is like with JVMs, you're doing interpretation of your code. But if you write, say, C code in a container, it's still that native C code running on your operating system. It's just isolated.
Yeah, exactly.
Yeah, it's really cool that we can bring our custom code in, but you had also mentioned that we can bring Azure services down. What kind of services work with IoT Edge today, and how does that look like?
Exactly. So IoT solutions are specific to each customer, which is why we allow you to bring your own business logic. However, we know that you don't necessarily want to reinvent the wheel every time you're writing an IoT solution, and you may be using some Azure services that you love, like Stream Analytics or Azure ML. Those are the two ones that we had in public preview, so they're obviously in GA as well. We also have Azure Functions, so you can write your custom code in business logic that you may have already deployed, or you can write a simple Azure function if you'd like. And we also have cognitive services. So things like image recognition, you can bring down, train in the cloud, but then score it locally on your edge device.
Oh, that's very.
That's really.
Yeah.
It makes it sound like wherever your code already is, you're just trying to make it easy to run on the edge, make it run on these small devices where you're just trying to get that decision made closer to where those inputs are being generated.
Mm-hmm.
Exactly. And like you said, it could be a small device, but it could also be a large server or something like that, depending on what type of equipment you're hooking up to, depending on what type of data you're processing and the frequency with which that data is coming in, and also depending on the type of processing that you want to run across that data, right? Like if you have a connected rat trap, hopefully you don't need too much processing or you have a really bad rat problem, right? But if you're connecting to industrial equipment, you may want to be sampling that data at 50,000 times a second and doing some kind of machine learning algorithm across that data. And that you probably won't be able to run on a device the size of a Raspberry Pi.
So one of the questions that I hear working with IoT Edge really comes along that low end. So how low can you go hardware wise?
So what we've shown is it running on a device smaller than a Raspberry Pi. That's around the sort of border of where we think it is. We're doing some tests right now to sort of give more prescriptive guidance. But really the limitation for IoT Edge is using a device that runs an operating system that supports containers, because that's one of the fundamental technologies IoT Edge is based on. In the future, we'll look at expanding Edge to non-containerized operating systems. But for right now, we think that hits the majority of scenarios that we want to target.
So could I
and
use this? Go ahead, Carl.
And just to be absolutely clear for everybody, I'm assuming that's all these dependencies, why sometimes it's a little bit smaller, sometimes it's a little bit bigger. It all depends upon our workload as well.
Exactly.
Yeah, if we're doing ML stuff, it might take a little bit more than if we're just doing like a quick like Azure function that's, making some very quick logic decisions.
Sure, yeah. If you want to process a few points of data with some Azure Functions, Raspberry Pis are more than enough to do that. Depending on what type of machine learning algorithm you want to run, you'll need more processing or compute. So, for example, image recognition. The accuracy with which you can detect an image or find a feature in an image not only requires computation, but it also requires reference data. So the more reference data you have to score new data, the more accurate it will be. And image data is large. So if you want to be very accurate with your scoring, then you may need 10 gigabytes of photo data as reference to your input. Whereas if you're in a scenario where you don't have to have as high accuracy, maybe you can get away with 1 gigabyte, and that really depends. That changes the storage requirements of the device on which you're running it.
Mm-hmm. I like this approach though with the modules and using containers, because I was thinking like, hey, it'd be kind of nice to be able to use like a Raspberry Pi for your home automation, and you can certainly do that. But then, if you do want to start doing this more sophisticated stuff, then you end up with a bigger machine. And it's kind of funny because there's like this whole community of people that write images for Raspberry Pi to do different things. Like there's one that will give you compatibility with Apple, what do they call it? Apple Home or whatever, the Apple HomeKit. And then there's another one that provides you like VPN functionality. And it's funny because they just expect you, because their Raspberry Pi is so cheap, to go buy like 10 of them and use like one for each workload. So this is obviously, a much simpler approach where you have this modular approach, and then you can start with something like a Raspberry Pi. And then if you outgrow that, you could just upgrade your hardware and just keep moving up as needed. So I definitely like that approach.
Exactly, and it speaks to the approach of you don't want to write all of your own code, right? You'll write code that is specific to your scenario. It may have some IP in there that you don't want to give away, but you may not have the skills, or you may not have the desire to write all the cloud services. Mm-hmm. The same goes with talking to like HomeKit devices, right? Apple can write a module that talks to their devices, and now you can easily ingest their data into your solution.
Exactly.
And so the great thing about the modules is that they're composable, and there's a third-party ecosystem for this. So folks can write general modules that anyone can use to get their sort of end-to-end edge solution to market faster.
Right. And then how they actually talk to each other. So if I have module A that's reading data from a sensor, and then I want to get that over to, my Azure function module that's doing some processing, how do I do that?
Gotcha. So like we've talked about modules, but if folks are new to Edge, basically a module is just a unit of computation. It could be a lot of computation. It could be a quick Azure function. But you take these units of computation and you link them together into a pipeline to create sort of an end-to-end scenario. So say you want to ingest data, you may have two modules. One module would read from the device. The second module may filter the data, and then you'd send the filtered data up to the cloud. The Azure IoT Edge Runtime provides a messaging broker such that those modules can pass each other messages, and that works really well for small message sizes. However, if you want to process, say, images, you don't want to be sending images through the system through multiple modules. And so what you could do is, since modules are implemented strictly as containers, you could open up a RESTful endpoint on a module and then have the machine learning algorithm read directly from that. So that's another sort of direct messaging paradigm as opposed to going through the broker. A third is you could stream data through an open port on a module, i.e. container. And we'll be coming out with some prescriptive guidance around that. But the main paradigm that we released at GA was through the messaging broker, because it makes it easy for people to conceptualize a pipeline of module A passing module B a message. Module B does some processing, passes it to module C. That module does something else, and so on.
Yeah. Would it be possible in the image scenario, would it be possible to store that somewhere on the local file system and then give the Docker containers access to that and then just pass around, let's say, a file name?
Exactly. Yeah. You could sort of, we jokingly call it the shoulder tap paradigm, where I read in an image, save it to disk, and then shoulder tap the next
your turn.
Tell them where to go get it.
Yeah.
Exactly.
Yeah. The what do they call that on the Event Hub team? They call that the coat check pattern.
Okay. There you go. Perfect.
Yeah.
Perfect.
Exactly.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com. So, when I'm working with an IoT device, a lot of times I think this is something that I'm having like a Raspberry Pi that has a lot of sensors or other hardware that I want to read values from. How do my modules gain access to interact with those different sensors?
So it kind of depends on which operating system you're working on. So Azure IoT Edge supports both Linux and Windows. On Linux, you just mount the device into a container like you would on any Linux device. It's usually under like dev whatever your device is. And then on Windows, you mount the device into the container. There's some issues around mounting devices into Windows containers right now, but the Windows team is doing work so that when they go GA, that will be a supported scenario. So right now, Azure IoT Edge is GA on Linux. Will be GA on Windows when they come out with the fall release, RS5, fall creators update. I'm not sure exactly what the name will be. There's like 16 different aliases going around. There's probably some build number too. Who knows what that will be? But there's an update in the fall. IoT Edge has some dependencies on those features coming in that fall update, and then we'll be GA once that hits.
Very cool. And then, we talked about this configuration where I have these modules that are sort of chained together, but that gives me this idea that I could sort of reconfigure those from place to place. So, I might install it at site A and I want to use these 3 modules hooked together in this pattern. At site B, I'm going to use these 4 modules. I'm going to put them together in different configurations. So how do I manage what that actually looks like? Do I have to modify that on each device? Can I manage that from the cloud? What does that look like?
So the idea around Edge is that all this is cloud managed. And in the cloud, you sort of set up canonical workflows for types of devices. Like the logic that you run on a smart camera is going to be different than the logic that you run on your oil rig or something like that. And so you can say, hey, I have my camera workflow and I have my oil rig workflow, and then target that at all of your cameras or target it at all of your oil rigs so that they get the right set of logic for the correct device.
Mm-hmm. Cool. And then if I'm just a module creator, and I'm not a person who wants to manage the edge, Microsoft built Azure Functions into a module, but what if I'm just Jason and I want to build a module that, doubles your data, so that's all I care about is building this module. And then I want to make it available for the world. Obviously I could put that on GitHub. Is there any other way that I can is there any other way I can get that out to the world?
Sure. So, modules are just containers, so you can put it on your favorite container repository and start the JSON marketing page. But it might be a little hard for people to find that. Obviously, you would talk about it on the MS Dev show.
Yeah.
So you might have a little bit bigger microphone than most people. But discovery is a huge problem that we want to help people solve. So we've started a module marketplace in the Azure Marketplace. And so you can go to the module marketplace and find modules that work with Azure IoT Edge, download them, and start using them immediately. Right now, modules in the marketplace are licensed under sort of a bring your own license. So you have to work with Jason. You can discover Jason's module in the marketplace and then have to work with him to figure out how much to pay him to use it. In the future, what we'd love to do is allow folks to do custom metering. So when you double people's data, you can charge them based on maybe how much compute it took you to double it, or the fact that you did double it instead of triple it or something like that. And these custom meters will be great for not only allowing you to charge what you want for your module, but then we can bill the customer using your module on your behalf. Okay,
cool.
That's pretty awesome. So as you've been working with people to, build the IoT Edge, has there been any interesting patterns you've seen with people in real time and real usage?
I think it's just generally the IoT pattern of let's first send all the data to the cloud. Once I've sent the data to the cloud, or the first thing is send data to cloud, and that's if you have a new device. then really where IoT Edge started as Gateway SDK was, oh my God, we have a bunch of legacy devices or new small power devices that we want to understand stuff about, but can't send the data to the cloud. So let's connect them and then send them to the cloud via an edge device. Once they have the data in the cloud, then they start running machine learning on it and finding some interesting insights about the data, and then sending commands back down to the devices to change or optimize their workflows. Once they start doing that, they're like, oh, well, I can optimize this farther by not going all the way to the cloud, finding those insights locally on the edge, bringing whatever cloud resources they were using in the cloud and running them locally in the edge, and then really doing sort of a tight loop of optimization and business logic.
That's a really interesting insight. I mean, starting with, pulling all that data to the cloud and working with it, and then pushing the functionality on the edge as you figured out. I was working with a partner, I think it was like 2 years ago. It was kind of interesting. I had an interesting conversation. There was somebody in the room who was, he didn't really understand manufacturing and like the quantities of data that can be involved.
Yeah.
And we were actually talking about motors, and he's sitting there, trying to sell the cloud. And it's just, a sales guy. And he's like, yeah, all the data comes off this motor, just send it up to Azure and we can use stream analytics, like the standard pitch.
Great.
And I was like, wait. I'm like, no, that doesn't work. I'm like, I don't think you realize the quantity of data coming off this motor. And it was funny because after I spoke, then the partner was like, yeah, we generally are generating 10,000, messages per second off of one motor. And we could have 1,000 motors in a manufacturing plant.
Yeah.
You just can't do that. Even if you have the fiber connection I have in my house here, like it's just not happening.
Like it's not physically possible.
It's just not physically possible. So what you can do is like grab some of that data, go start working with it in the cloud, figure out what is most interesting to you, and then actually push that down. So I think that's obvious. That's a really common scenario. I mean, you can say the same thing about like wind speed, right? Like if I just had a wind sensor at my house here, like I could measure 500 times per second if I wanted, but I'm probably going to find that that's, really what I want is the highest wind speed value for any given 5-minute period, for example. And then I
sure Azure network and storage would be happy that you're monitoring 500 times a second.
Yeah, if you want to do that, that's great.
By all means, they'd be happy to store that data.
My paycheck. Absolutely.
So before you had mentioned the IoT Gateway SDK, and I think that IoT Edge kind of has some history there. When we look at like IoT Edge, is this optimized more for being that kind of gateway device for other connected sensors, or is this meant more for putting on something that's an IoT device to directly communicate to the cloud, or is it kind of like the best of both worlds where you can kind of do both?
Yeah, it's definitely both. I go back to scenarios are so customer dependent that it's really about where you want to run your code. Like I try not to use the gateway term specifically. I just talk about classes of devices of you may be connecting a device to another device and that device is called a gateway, or you may be processing some data from other devices on this intermediary device and that's called a gateway. Like I look at gateways as human children. Everyone has all human children are all children are human, but my child's special, right? Like my child is something different than your child. And that's kind of how gateways are. Everyone can sort of understand the concept of a gateway, but when you get down into the nitty gritty of what a gateway does, like it varies widely. So just like Azure IoT Edge is extensible, like you can really build an edge machine to be that leaf device, and you want to run some machine learning like locally on the data that it's consuming, or it might be an intermediary gateway that's collating data from across your factory floor, and you want to sort of gain insights about how your factory's working. And
then you could chain these things together as well, right? I mean, not just modules, but also the edges.
Coming soon.
Okay.
Daisy chaining gateways is a feature that's on our backlog, and we know people want to do that.
Okay.
There's a few technical limitations around that right now, but yes, in theory, you can do that, and you'll be able to do that.
So it'd take a little bit of work if I want to do it today, because I'd have to do my own custom communication. Okay, that makes sense.
Yeah.
And then I think we should address, what's always the elephant in the room, which is security. So did you guys put any into this?
No, not at all.
Yeah.
What's security?
TBD. No, it's on the backlog.
Yeah. No, so The way we view security is that for IoT scenarios, you need a higher bar of security. If your gateway is locked off in your OT server closet somewhere, that needs a high bar of security. However, there's a higher bar if your device is out in the wild where an attacker may have physical access to it and an unlimited time with it. And so Azure IoT Edge is designed such that it integrates with firmware, so like a TPM or some kind of hardware security module, and it will attest that you're not only running the right workload, that the workload hasn't been tampered with, and things like that. So we've put a lot of thought into the security model for IoT Edge.
Yeah, I think the security model is great, because you want to have that end-to-end security and verification at every stage. I know you guys have put a lot of work into that. One of the it's actually kind of interesting because in the manufacturing world, they actually count on things being like open and sort of insecure because that's how they sort of move data between places.
That's how it started.
Yeah, but I love that there's this stand of like, hey, this thing it's secure by default. And if you want to do that data sharing, then we have to figure out a way to enable that without compromising security. So, I applaud the team for doing that. And also just the amount of security rigor that is really comes down from like the high levels at Microsoft and has to go into all this stuff because, everybody is super paranoid about security. And I know you guys have thought about it from the beginning versus like some of this, some of these cameras that you put in your house where, really they slap security on
door lock and it comes out with like a hack and like your door's just now available for anyone to walk.
Yeah, we talked about the fingerprint lock on the podcast, and man, there was basically no physical security. There were so many issues with that thing. Obviously, it's funny because they were literally building a lock. And it felt like they just did not take security very seriously.
Yeah, it's a secure device, right? Like a lock is designed for security, and then you don't put security into your lock. It's kind of ironic.
Exactly. So that was more of just a comment on the security there.
Yeah. So, one thing that I've seen is people looking at this technology and comparing it to other Microsoft technologies, especially something like Azure Stack. Mm-hmm. So is there a real comparison to be made? Is there a situation where you might be evaluating using IoT Edge versus Azure Stack?
You could use them in conjunction. So Azure Stack is more about it's services, but it's also a prescriptive set of hardware, right? Like, so it's, I think, at least 4 blades, so a large server, which is expensive. And there's a set of people who want to run those services on devices that are smaller. So if you have a scenario where you're processing a ton of data and you really want all of Azure locally, Azure Stack's a great option. However, for those situations where you may want less than 4 racks, Azure IoT Edge and whatever hardware you want to choose is a great option for that. And that lets you run partial cloud services on Edge, not the full cloud service. And that gets to sort of a conversation about what should I really be running on the Edge versus running in the cloud. And there's certain workflows that make sense for one versus the other. So for example, if you take machine learning, training a machine learning model takes a lot of data. It takes a lot of compute. Unless you want it to take years. And it probably takes a lot of memory. That's not a characteristic that you probably want of your edge device. So if you do your training in the cloud, then you can create a model relatively quickly and cheaply in the cloud, and then ship that model down to your edge device for local scoring. Because scoring doesn't take that much memory, compute, or anything like that, but you can get your result very quickly.
Okay. And then, so, that kind of covers the Azure Stack aspect, but how does this compare then to something like Kubernetes or some other basically container orchestrator?
Gotcha. So Azure IoT Edge is not a container orchestrator. IoT Edge starts modules which are containers and just makes sure that they're running. However, that is not true container orchestration. Container orchestration is, hey, I have 4 nodes and I want these 5 containers to be always running across these 4 nodes. That's a very hard problem that Azure IoT Edge does not attempt to solve. We want true orchestrators to do their job of orchestration. And so when we look at scenarios around high availability and disaster recovery, that's what orchestration is great for. And so we're going to, in the future, have Azure IoT Edge integrate with those true container orchestrators such that you can, from the cloud, specify a workload that will run on the edge, and then Azure IoT Edge Runtime will make sure that it gets the correct workflow, and then delegate that to an orchestrator to run locally. And I believe Venkat, another colleague of mine, showed some initial thought process towards working with Edge and Kubernetes at the same time.
Very cool. Very cool.
So one of our favorite questions when we're talking about like new Microsoft services is how much does this cost? It all sounds great, but what's this going to run me when I actually put this out in production?
$100 million. So Azure IoT Edge
but for
free.
you, for MS Dev Show listeners,
exactly.
we have a
For you
special
guys,
offer
today and only today with coupon code MS Dev Show. No, so Azure IoT Edge is free. Like basically, we just want to make it easier for you to run Azure services locally. You'll pay for your Azure services per service. So some of them are free, like machine learning, for example. They charge you for creating a model in the cloud, but you're using your own hardware and your own electricity to score the model locally. Like you paid for the device, so just go ahead and use it. Like they want you to use Azure ML, whether it's in the cloud or locally, and they'll let you. Then they'll share split the price difference with you. And so each service or custom module, if Jason wanted to write his double your data module, gets to choose how much they charge for that service. But Edge is just sort of the substrate that runs it for you, and we believe that should be free.
Okay, very cool. And then how does somebody actually get started with this thing? Like where should we send them?
So we have some documentation. I'm sure in the show notes you can show one of our tutorials to like the Linux or Windows Quickstart, and that will get you up and running. It will deploy a simulated temperature sensor that just sort of spits off random temperature values and sends it up to IoT Hub. And then there's some following tutorials where you can write a custom module to filter it. You could write an Azure function to filter it. You could write a stream analytics query to do some kind of was it an average over a floating window? And then there's also a tutorial about how to run machine learning over that data as well.
Okay, very cool. Anything else you wanted to mention? Any cool upcoming features you want to talk about? Wanted to tease?
Oh man, I mean, we've been talking about all of our customers ask for high availability disaster recovery. So those are things that we're definitely working on. Offline is another scenario that's super in demand. So right now,
I've heard that.
You need an Edge device to be connected to the cloud so that you can specify the workloads running on it. And then once the workload is running on the Edge device, the connection can be dropped for a short period of time, but we use SAS tokens for security, and SAS tokens need to be refreshed. They need to be refreshed from the cloud. So then if for some reason your device is offline for a while and reboots, it won't be able to refresh its SAS tokens. So the first thing that we want to do is just fix that such that your device can be offline once it's provisioned for as long as it wants and restart. Then once we do that, then we'll sort of look at sort of how do you configure the device offline, and then how do you even provision the device offline.
Okay, very cool. Very cool. Okay, Carl, what do you have for the Azure pick of the week?
So I know we've mentioned Azure Functions several times throughout here, but another place it can now run is in Kubernetes.
Oh, that's cool.
So we have a link in the show notes that'll take you to GitHub documentation on how to deploy Azure Functions anywhere you want with Kubernetes.
Yeah. So, I think we've talked about on the show, like you could, for a long time, you've been able to take a function and package it in a Docker container. And I've gotten that working in Kubernetes, but it looks like they've essentially brought there must be some extra tooling around that to make it even better.
Yep. And there's examples on, how to do all sorts of things like minimum and maximum instances, how to retrieve your function logs from there, integrate it with your cube config files, all that stuff.
Yeah, because I've prototyped like getting all my websites and everything that I running in basically AKS, the Azure Kubernetes service. And so I have like a private prototype running, including the MS Dev Show. And actually, one thing that we never really followed up on was I do have the MS Dev Show website running in blob storage now that it has the new website feature. And I also have it working with a CDN. So I know you and I have been talking about switching that over. So maybe we'll bring that up again if we ultimately make the switch and just serve that from blob storage and a CDN, which should make it faster for everybody. And then we don't have to, it's interesting. It's like we used to have to deal with servers, then virtual machines, And then it was like
I think
Docker
we've deployed
containers.
it using every potential Azure or
I've had
cloud
MS
technologies.
everywhere. Yeah. But we're getting to the point now, I know
What's the easiest and cheapest way to do it?
Yeah. We've run it on websites, and now we're just getting to the point where it's like, well, now we're not even like running it. We're just literally saying, please serve these files. We don't want to know any of the implementation. So, I thought that was very cool and worth mentioning. Okay, so Chipalo, where can people find you?
Sure. So you can find me at LinkedIn. Is there LinkedIn handles or whatever? I'm Chipalo Street. There's probably only one of those. It's not too hard to find.
Okay.
You can also find me on Twitter at Chipalo ST. I probably have like 3 followers. If I get 100 followers from this show, I will start tweeting to people whatever they want. Well, not whatever they want, but
oh no, I'm gonna edit that
on a
second
more
part out.
regular basis.
I'm gonna edit that other part out.
There you go.
Yeah, so definitely go follow Chipalo. Follow Chipalo. Hey, that's awesome. Follow Chipalo. And let's see, what should we do? So then Chipalo will start answering any question that we want. So that sounds like a pretty good deal.
I'll answer your question. That's not a problem.
That sounds like a really good deal. And where can people find you, Carl?
You can find me on Twitter at Carl Schweitzer.
And you can find me on Twitter at twitter.com/ytechie. So Chipalo, thank you so much for coming on here and talking about the IoT
Anytime,
Edge.
This is great. Let's do it again.